And we are going live. All right. Everybody's joining up. Okay. Okay, let's go ahead and get started. We are going to pick it up where we left off last time. We left off on balancing nuclear equations down in the lower right-hand side. That's the Penn State page. That's part of the nuclear packet, part 2. So first up, we left off on number 17, which I have on the big board here. So I'm just going to go ahead and knock a few more of these out. 235 and 1, so I got 236 on top, 92 on the bottom, and I'll do the top part first. Got 236. This is the top part. I've got 2 on top, which is 234. And then I got 95 to subtract out. So let's see here, 2, 14, 9. And 1, 12 would be 3. 139 on top. No. I mean, I haven't seen it. I'm gonna go ahead and do the bottom. Bottom is 92. Times 0, 0. I've got 42 to subtract out, which is going to make it an even 50. Get a periodic table. And in box 50, we have 10. It's number 17, balancing nuclear equations from the Nukes 2 packet. Number 18. Looks like here we got an alpha particle. So let's go ahead and do the top. 6 plus 1 is 7 on top. 3 and 0 is 3. Do the top first. So I've got 7. And I got to subtract out that 4. That's going to give me 3 on top. And then do the bottom. I've got 3 on the bottom. I've got 2 in play. 3 minus 2 is 1. And that is going to be H. That's going to be the tritium isotope of hydrogen. Let's take a look at 19. Let's see. 9 plus 2, 1 H, 2, 7, 4, B plus blank. All right, let's do the top first. 6 plus 2 is 8. And then on the bottom, we've got 3 plus 1 is 4. So we'll do the top first. Take my 8 over. I'm going to subtract out that 7. It's going to be 1 on top. On the bottom, I have 4. Got 4 here. 4 minus 4 is 0. 1 over 0 is going to be a neutron. 19. Okay, number 20. 121. Antimony. 51. SB plus blank. So again, we're going to do the top. 121 plus 1 is 122. We'll do the bottom. 51 is 0 is 51. And the top over. 122 minus 122 is 0. Skip the top. And on the bottom, 51 less 51 is going to be 0. And that can only be a gamma particle on number 20. Let's see here. Next up, 21. Got 214. 52 PB. 2, 0. Okay. So we got 214 on top. That slides directly over. And we got a -1 here, so we got to kick this up by 1. It should be 83, and 83 should be bismuth. Yes, we are correct. That is 21. Essentially what you did was you emitted a beta particle on 21. It's a beta emission. Two. 63. So we're going to add the top. 63 and 2 is 65. Add the bottom. And 1 is 30. Do the top first. 65. Got 3, which would be 62 on top. Bring the bottom over. It's 30 plus 1 is 29. And box 29, we have copper. That is number 22. Let's see. 23. 7N. plus 1H. In this case, we have to add up. Since the particle's missing on the left-hand side, we are going to have to add the top numbers on the right and the bottom numbers on the right. So on top here, we'll have 14 plus 1 is 15. And then on the bottom, 6 plus 1 is 7. Bring the top over first. 15 minus 14 is going to be 1 on top. And then bring the 7 over. 7 less 7 is 0. And 1 over 0 would be a neutron. And that is number 23. Four. Do the top. 6 plus 1 is 7 on top. And then we have 3 and 1. We have 4 on the bottom. Bring the top over. This is the top. Got 7. Knock out that 4. I'm going to have 3 on top. That's going to take care of the top. And on the bottom, bring that 4 over. Take that 2 out. And that is going to be helium isotope. HE there. And that is number 24. 24. Let's see here, we're going to add the top on this side. Again, we got to start on the right because the left's completely blank. 237 would be 241. Bring that right over with 241 on top. Then do the bottom. 93 and 2 is going to be 95. Bring that 95 right over. And then we find box 95. We have americium. And that is for 25. In fact, americium, little sun. If you have any smoke detectors at home, this is what's inside that makes the smoke detector work. It emits alpha particles. And the alpha particles, when the smoke enters the chamber, blocks the alpha particle flow in the circuit, and it trips the smoke detector. That's how smoke detectors work at home. Bar on that one. Six. We got 2-1H plus 2-1H. 3-2H. do the top first. 2 and 2 is 4 on top. And we have 1 and 1. We have 2 on the bottom. Bring the top over. 4 less 3. Again, this is the top. It's going to be 1 on top. And on the bottom, we had 2. Minus 2, 0, 1, 0, can only be a neutron. Number 26. That is 26. Seven. 18. First thing you saw on number 27 is D. That's deuterium. That's just the second heavy isotope of hydrogen. That is indeed hydrogen. It's just they use the D symbol for deuterium there on that. So I'm going to add the top. 28 and 2 is 30 on top. And 14 and 1 is 15 on the bottom. So we're going to do the top first. I'm going to take 30. I'm going to subtract out the 29 and get 1 on top. Looks like it's going to be another neutron. Maybe. Nope. 15. Again, this is the bottom. 15 from this side, 14 down the wall. 15 minus 14 is 1. And that is just going to be a plain old hydrogen atom, proton, going in there on 27. That is number 27. This one, not very challenging mathematically. Let's see, so we've got 9 and 4, we've got 13 on top, and 6 on the bottom. So we're going to do the top first. 13 less 6, and that's going to be 7. And that's the top. For the bottom, we got 6 plus 3, 3, 7, 3. That's going to be lithium. Lithium 7. 28. $59, $59, cobalt, and 260, 27, cobalt plus blank. All right, let's do the top first. 59 and 1 is 60 on top. And then on the bottom, we have 27 and 0, it's 27. We'll do the top first. So we'll take the 60 and subtract that 60, and that's going to be 0 on top. And on the bottom, 27 less 27 is 0. 0 over 0 is going to be a gamma particle. 29. $30. Let's see, 40. 18. Argon. H. 2. 1. Argon. So let's take a look at this one. 40, 42 on top. 18 and 1, 19 on the bottom. The top first. 2 plus 41. 19 I needed, I erased it. 19 less 18 is going to be 1. This is the bottom. 1, 1 is going to be a proton. It's number 30. It's going to be a proton. Okay, let's take a look at 31. 14, 7N, plus 4-2HE, 2-1H, blank. Going to do the top, 14 and 4 would be 18, and on the bottom, 7 and 2 is 9. So we've got 18 minus 1, 17 on top. On the bottom, we've got 9 plus 1 is 8, 17 and 8. Box 8, you will find oxygen. That is number 31. Let's keep on chugging here. 32, got 18.9 fluorine. Going to 18.8 oxygen and a blank. So we've got 18 slides over, so it's going to be a 0 on top. 9 minus 8 is going to be 1. And let's see, 0, 1 will be a positron. Haven't seen a positron in a while. It is a positron, which is classified as what's called antimatter. Okay, let's go to 33. We got BE plus 42G, 212.6C plus blank. So we got 9, 12, 13 on top, and 4 and 2 is 6 on the bottom. So we'll do the top first. 13, have 12. 13 minus 12 is going to be 1 on top. And 6 and 6. 6 less 6 is going to be 0. 1, 0 is going to be a neutron. That is number 33. Okay, 34. 239. GU 20. Let's take a look at this. 239 is going to slide straight over. And we got to go up from 92. We have a -1 here. So that means we got to put a 93 in there. And that is going to be plutonium 239. $35, 32, 16S, and 32 and 1 is 33, and 16 and 0 is 16. 33 plus 1 is going to be 32 on top, and 16 on the bottom. 16 on the bottom. I've got 1 there, which would be 15. And 15 phosphorus, yes. Phosphorus 32 isotope. That is number 35. $36, 239, 94, plutonium plus 2. Whoa, back the bus up. That's a coefficient there. 210N, 2 beta particle, and a blank. Okay, remember when you have a coefficient is superscript times subscript, you have to factor in both. So 239 plus 2 is going to be 241. And 0 is 0, so on the bottom, I'm going to have 94. Okay. So let's do the bottom first. I have 94 to make, and I have a -1 here, so that's going to have to be a 95, because a 95 and a -1 will get you 94 net. So the bottom is done. Then we do the top, because the top's easy. Since there's a 0 there, you take that 241 and you slide it right over. And in box 95, we have Americium. That is number 36. Okay. 37. Titanium, 2, 0, E, and black. So we got another beta particle here. This one's pretty easy. We're going to take that 237, since there's a 0 and there's nothing else to add here. You're going to take that 237 and you're just going to slide it right over on top. Then let's see, you've got 89 to make, but you have a -1 there. So essentially you've got to take that -1 and add it to this 89. And we'll make it a 90, because 90 and a -1 is 89. And in box 90, we have thorium. All right. 37. $38. We've got 237 thorium going to 233 radium and blank. So let's take a look here. We'll do the top first. Top, we got 237. I'm going to subtract out the 233, and it's going to be 4 on top. And then we'll do the bottom. Bottom, we got 90. And subtract out the 88. We got 2. And we have a classic alpha particle emission here. Stick in the symbol. And there it is. That is number 38. That is an alpha particle. $39. We got 235. Year, 2, 2, blank. And this looks like another alpha particle here. So on top, we have 235, and this is the top. I'm going to take that 231 out. That top's going to be 4. Bottom is going to be 92 minus 90. Be 2, and that's going to be another alpha particle on 39. see the last one on that page. Number 40 will be 231, 90 thorium, going to 231, 91, PA, and let's see here. See 231, 0, and 91 minus 90, we are going to need a 1, and a 0, 1 is going to be, oh, I did the math wrong there. I'm going with a positron. There it's 91 minus 90, which would be -1. That's going to be a beta particle. I was going to stick a positron in there. Now that's a beta for number 40. And that takes care of the Penn State page entitled Balancing Nuclear Reactions. That page is done. Probably just going to go ahead and finish out the packet in terms of the reactions today. So our next top is going to be the page, looks something like this. It's going to be in Nukes 2. And it's going to be balancing nuclear equations. And you found the page. If you found the page, it's going to have a chart. It's going to go through the types of particles, alpha, beta, beta capture, and gamma. There's a chart right up here. We're going to jump right in down to the reactions. So, and it's marked. It's marked practice. So number 1. We've got 3,1H going to blank plus 0, -1E. Oh, let's see here. Well, it looks like the 3 is just going to slide straight over for the top because we have a 0 there. There's nothing there to subtract out. And on the bottom, we've got to go up 1 because our net here on the bottom, our net has to be 1, but you have a -1 here, so you have to put a 2 there. The 2 plus the -1 is going to get you 1, and that's going to get you an isotope of helium for that first one. Okay, that's number 2. Let's see, 232, 92U, 228, 90 thorium plus blank. So let's see here. Got a top. On top, we have 232 minus 228, and that's going to be 4 on top. Bottom, -92 minus 90, it's going to be 242He. That's going to be an alpha. It's going to fit in there. And that is number 2. Three. Let's take a look here. All right. 144 and 144, the top has to be 0, and there's no net change. We got to go from 59 to 58, so we need a -1 there, and that's going to be a beta particle. This, some of these are really easy. Slide that top number straight over. 65 and 0 will still get you 65. And for that bottom, we've got 30 and a -1. So we need a.
That's supposed to be a positive one.
Well, it's a positive one?
Yeah.
Positron, thank you. Yeah, that's going to change the math. Let's see, that's a positron here, not a beta. So that's going to change our math, because then we're going to have on the bottom, we're going to have 30 minus 1 is 29. And 29, I believe that's copper. Yep, correct. Yeah, watch your signs, because there's a big difference between a positron and a beta. So beta, you're going to go down 1, positron, go up 1. So that's number 4. Hold on here. Number 5. Argon. All right. Looks like another easy one here. We're going to slide. We got 40, we got 40, got a 0 on top. Let's see here. We got to get 19 on the bottom. We have 18. It's going to be 1, and that is going to be a positive 1, and that's going to be a positron. That's it's number 5. There we go. Number 5. All right, let's go flip the page. On the back side, we start with number 6. We've got the 7-4 beryllium going to a 7-4. Oh my gosh, these are easy. Blank. So here you have no mass change, no atomic number change. It can only be a gamma. Gamma, again, it's your only particle where you have no mass and no atomic number. So that was easy here. That's low-hanging fruit. Got number 6. Seven. All those blanks are there for. Okay. Double arrow. Sure what's going on there. Is that all the same problem? We got 2 arrows. Okay. Well, let's see. 141, I'm gonna guess this is all one here. And 92, 37. Blank. So let's see what happens. 236 on top. We'll do the top first. 236, and I'm going to subtract out the 141. Get here 5, 2, 1, 13, 12, 11, 10, 9, 95. And I've got 95 less 92. It's going to be 3 here. And let's do the bottom. We've got 92. So we've got 92 minus 55, 8, 12, 7, 37, and 37 less this 37. It's going to be 0. So we got a 3, 0. The only thing that's going to fit there, so we have to break out a coefficient and convert this into a 3, 1, 0 neutron. And that will give us the correct piece for that. That's number 7. Number 8, we got 222, 86, 2 blank, HE. So we're going to do the top first, 222, we bring that over, and subtract 4, and that's going to be 218 on top. Bottom, got 86 plus 2, it's going to be 84, and that's, I guess here, that's polonium. Yes, that's right. Polonium. Number 8. Let's see here. 29, 53, adding to 29, 54, xenon. Okay, 129, slide straight across, so the top has to be a 0. And we got to get from 54 to 53. It looks like a beta particle. It's going to fit right in there and knock number 9 out. That's number 9. Number 10. 239. So let's see here. Single particle on the right. So we're going to take that top, that 239. We're going to subtract out that 4, and we're going to get 235 on top. Again, 235 plus 4 makes 239, which is the mark to make. And on the bottom, let's see, we are going to have 94, plus 2, 92, and that's going to be radium. There for number 10. And that is number 10. Number 11, 15, 8, 0, 2, 15, 7, N plus black. Oh, these are looking pretty easy here. 15 slides over, so the top has to be a 0. You've got 8 on the bottom. So you're going to have 8 plus 7, which means we need a 1 there. And that's going to be a plus 1. And that's going to be a positron. 7 plus 1 gets you 8, 15 and 0 gets you 15. Okay, got some word problems here. So let's take a look. It says, write a balanced nuclear equation for each type of the decay process indicated. You got the isotope of thorium, thorium-234. I believe that's number 90. Double check it. Yes. And that is going to decay by alpha emission. What that means is when it decays, emission means you emit that alpha particle. Again, that's our alpha particle, and then we have the missing isotope. So let's see here. On top, we've got 234. Minus 4 is going to be 230 on top. And then on the bottom, we're going to have 90 minus 2, and that's going to be 88. And that's radium. That is that one. That is number 12. 12A, I should say. That's 12A. Let's look at 12B. Got the isotope of iron 59. And that's number 26. Correct? Yes. And that undergoes beta emission. So we're going to emit a beta particle and a blank. So mass is easy to do. Take that 59 and you slide it straight over. The atomic number, got a -1 there, so you have to kick it up by 1. So 27 would be the bottom number. 27 plus -1 will get you 26. And box 27 is cobalt. Yes, it is correct, cobalt. And that is, put the number up there. This is number 12, and this is B. 12B. Let's take a look at 12C. 12C. Got technetium 99. I think that's 43. Oh, right. Oh boy, sometimes it's just lucky guess, I guess. And this decays by gamma emission. So gamma and no net change in mass and no net change in atomic number. So you write technetium over on the other side. That's 12C. And we got 12D. Isotope C11 decays by electron capture. What that means is that's going to capture a beta particle, because a beta particle is the same as an electron. Capture means it's going to be on the reactant side. And we just got to figure out what the missing piece is, or D. Let's take a look.
How do you determine if that electron is going to be negative or positive?
Electron is negative. A positron would be positive.
Oh, yeah, okay, yep. All right, thank you.
Difference between a positron and an electron. A positron is antimatter. So let's slide that mass over. That's going to be 11. That's easy. And here, let's see 6. And you got to remember you're dealing with a -1, so you got to drop this number by 1. And that's going to be 5. And that's going to be boron. Correct. That is 12D. So we are on to number 13. Okay. And 13. Okay, 13. We've got 1,1H plus 7,3 lithium. And we just need the product. I like the simple addition. 7 plus 1 is 8 on top. 3 plus 1 is 4. We're going to have 8 and 4. That's going to be a very, very heavy isotope of helium on that. Let's see, number 14. There's no way that helium is going to be stable with that kind of mass. Number 14, 7 for beryllium, plus a neutron to some type of hydrogen isotope, plus so let's see what we got. We got 8 on top. So we're going to use the stable isotope for helium, because we need a number here. So we're going to put a 4,2. We're going to make that an alpha, which is the stable part. That allows us to finish the problem, because we can't do a problem with 2 blanks in it. So 7 plus 1 is 8 on top, and then I'm going to subtract the 4, get my top number. 8 minus 4 would be 4. And on the bottom, that is not going to be hydrogen, folks. Because on the bottom, you've got 4. 4 less 2 is 2. That's going to be a helium atom there, too. Okay. That one doesn't make any sense. I don't know why they left those 2 blanks there, but they did. And that's 13 and 14. And give us something different here. Yeah, number 15. Got to write a balanced equation for the reaction of curium-246. Curium to CM. Find that one. Yeah, curium CM246. I need the number is 96. Okay. Reaction of curium-246 with carbon-12. That one's easy. To produce thallium-254. just wants us to write this out. There's nothing to balance. We just need to find the numbers and the symbols. So nobelium. Where are you hiding? Number 102. And 4 neutrons. There's 4 neutrons. And I'm assuming they're math checks. Let's see, 246 to the top, and 12 is going to be 258 and 254. 4 times 1 is 4. The top checks out. That's 258 on both sides. And the bottom is going to be 102. That was easy. 96 and 6 would be 102. 102 equals 102. The math there checks out. Okay. 16. Write a balanced equation for californium. 250, californium, 90 something, 98. With boron 10, produce Lawrencium 258. And that's 103. And 2 neutrons. It doesn't hurt to check the math. 250 and 10 on top is 260. 258. 2 times 1 is 2. The top checks out. 260 gets 260. And the bottom, let's see the bottom. Let's see, 103, 98, 2 would be 100, and 3 would be 103. 103 gets 103. The math on 16 checks out. That's good. Another page out. Yep. So let's go to the very next page in the packet, and that will be entitled Nuclear Reaction Worksheet. And if you're following along, to one pager, and that first one, problem number 1, is going to have polonium in it, PO. So that first one, boy. It's going to be 212. Printing was not of high quality. All right, let's take a look at this. 212 minus 4, and that's going to be 208 top. Okay, bottom would be 84 less 2 would be 82, and that's going to be lead in there. And this is number 1. C61 promethium plus blank goes to neodymium. So let's see, we got a 142, so we needed 0 on top. There's no mass change. And we've got to go from 61 to 60. And that's going to be a beta particle sliding in there. Number 2. Let's see, number 3. Got 253 styrene plus 42 Hg to 1 neutron and a blank. Okay. So I'm going to add the top. Be 253 and 4 will be 257. Bottom, let's see, 99. 101 on the bottom. So do the top, 257. Again, this is the top, 257 plus 1. It's going to be 256 on top. And on the bottom, got, let's see here, 99. Total 101. I have 0, so I'm going to slide that 101 in there, and a box 101 have Mendelevian. That's number 3. Let's see. 4. 218. This one. So we're just going to take the top, 218. I'm going to subtract out that 4, and that's going to be 214 on top. And then on the bottom, go 84 less 2 is going to be 82, and that's going to be lead. Number 4. Number 5. Let's see, number 5. That looks like an 11. Oh, it's a 9. 9, 4 beryllium plus 4, 2, 8, 0, and plus blank. Okay, so let's see here. 9 be 13 on top. And on the bottom, we're going to have 6. So we bring that top over first. 13. 13 less 1, it's going to be 12 on top. And bring the 6 over next. So there's nothing here. So I'm going to slide that 6 in, and that's going to be carbon number 5. Number 6. Got 2 sodium plus blank 2 neon. All right, let's see here. Mass looks easy. 22, 22. Mass has to be 0. got to go from 11 down to a 10, so we need to take a step down. That's going to be a beta particle is going to slide in there. Oh, so nice. Number 6. Seven, 238, 92U, 2 blank plus 244, 90 thorium. So let's see what we got going on here. We've got 0 on top, and we're going to need 2 on the bottom. 92, 90 plus 2 is 92. So the only thing that's going to fit there, let's see, that's 0 on top. So we are going to need 2 positrons. Nope, I made a mistake. I've got 238. There is a mass change. Just caught that. I've got 238 on top. I thought that was 234. It's 238 less 234 is 4 on the top. So there is a mass change. That's a game changer. And 92 on the bottom. Call that 92 minus 90 is 2, and that's going to be an alpha in there. Number 7. I made a simple problem complicated. 8. Got 37. Argon 36. 18. Krypton. Okay, argon blank 37, 17 chlorine. Now, there is no mass change here. 37 and 37, that is indeed 0. We do have a step down in atomic number. So I'm going to go with a beta. 18 and -1 is 17, 37 and 0 is 37. And that's going to work on number 8. And number 9. Write a nuclear equation for the decay of polonium. It's 84, 210, polonium 84, that is correct. If it undergoes 2 consecutive alpha decays, we'll start with the first alpha decay. And an alpha decay is the same as an alpha emission. So you're going to write your alpha particle, and we need the isotope in the box. So on top is 210. 210 minus 4 would be 206. 84 less 2 would be 82. And we want lead. Now to keep that isotope, that's called the daughter isotope. And that's going to get used in the next step of the decay process. So I'm going to take that 206, 82 PV, because that's the first alpha. So I've got 1 alpha, and I need another alpha. So I'm going to need this isotope to do the third step. So 206 less 4 is going to be 202. 82 less 2 would be 80. And that's going to be mercury. So I need the 202, 80 Hg. That's the second alpha. Okay, 2 alpha decays followed by a beta decay. So under this one, it's going to undergo for the beta process. All right, in my beta, and then I need the next daughter isotope. So I'll box this one. So mass slides over to O2, and I need to step up one here. 81, -1 would be 80, and that's going to be, I think that's thallium. 81, yep, got thallium in there. So I need that thallium isotope. 202, 81 thallium. Let's see, followed by a beta. I got it, followed by another alpha decay. And the last step, this is going to decay by alpha. I'm going to put in a blank. That's going to be so 202 less 4 is going to be 90, 198. 202, yep, that's right. And I'm going to have 80, 79 down here. Yep. And a box 79, that's not ringing any bells. Gold. And that is our product after the last alpha decay. So let's see here. On number 10, write a nuclear equation for the release of a beta particle by lead-210. Okay, so we got lead-210, and it's going to release a beta particle and the isotope. So let's see, 210, the mass slides over. You've got 82 and 1, so you need to get to 82, so you have to put 83 there because that's a -1, and that's going to be bismuth. Any questions there? Is number 10. That, go ahead and do this one. Do number 11, since everybody's still here. Number 11 is a decay series. In a decay series, you've got multiple steps to complete. So you've got thorium-232, that's number 90, undergoes radioactive decay, right? The reactions of the decay process for thorium. There are 11 steps beginning with an alpha decay, and each product becoming the reactant in the next decay. That's called a decay series. Okay? Then circle the final isotope. Well, first up, you're going to undergo alpha, and that's the first one. So we're going to take 232 less 4 is going to be 228, and 90 less 2 is going to be 88, and it's going to be radium. Yes. So I take the 228, 88 radium, and that undergoes, in the next step, a beta decay. And so I put a 0, -1e for my beta, and then I need the next isotope. I've already used purple. Go with orange. All right, so it's going to be 228, and I got to kick up one here, so I need an 89. And 89, I'm going to have actinium. So, is the beta decay. So I'm on to another beta. So next one, I take the 22889 actinium, and that goes under a beta decay. Now, so that's 228 on top and 89. We have to kick it up one. 90, in box 90, we have thorium. So we take the 228, 90 thorium. That's going to undergo an alpha decay and another isotope box. So 228 less 4 would be 224. And 90 less 2 would be 88. We're back to radium. So we got 224, 88 radium. And that's going to undergo an alpha decay. So 224 less 4 is going to be 220. 88 less 2 would be 86. And that's going to be radon. So I take that 220, 86 radon, and I'm going to do another alpha decay on it. So 220 less 4 would be 216. 86 less 2 would be 84, and that's going to be polonium. So in the next step, I take that 216, 84 polonium, and that's going to undergo an alpha decay. And another isotope. So 216 less 4 would be 212. 84 less 2 would be 82, and that's going to be lead. So I'm going to take the 212, 82 lead, and that's going to undergo another alpha decay. So 212 less 4 would be 98. Be 198. No. 208. I'll get there. Okay. And 82 less 2 would be 80. And that's going to be mercury. So I'm going to take the 20880, and that's going to undergo a beta decay. Let's see, 208 for mass. And I
How did you get 80 for the last one?
Well, you're going to have to read it back to me because I erased it. What was the equation?
When I can find it. Which one did we just do? I don't even remember.
I've got, okay, after the last alpha, I should have had 218, 82 lead. That should have been the last alpha product. Is that correct?
I got 21282.
212.82. Okay.
I think we started with the wrong thorium at the beginning.
Okay, what do we have?
We started with the 232 thorium, and we're supposed to start with 238.
38, so everything's going to be off by 4. Okay. How about we pick that one up Thursday? We'll start that one over on Thursday.
Because Max and I were just like doing it together, and I was like, wait a minute, what? How did we get that?
I read the thorium 232, but they said write the decay series for the thorium 238. So that's going to make everything off by 4. And
Okay.
so that's one I'll make a note on that. But that's where we'll start it on Thursday.
Okay.
We'll do that decay series for Thursday. And I'll know to start with the thorium. Then we'll walk through it there. Okay. Yeah, because I went with 232, and that's gonna, yeah, that'll change the math. Is there anything else? Anything else? Still plan on getting the exam out either Thursday afternoon or Friday. And then you'll have 1 week to do it. And is there anything else?
Is this going to be a paper copy again, or is this
No,
online?
this is going to be a online thing. What I'm planning on doing is essentially taking my paper exam and just formatting it to a multiple choice type format, which you can go ahead once you've got it. It's going to come out as a Word document, and then you can just go ahead and put in the letter or highlight the answer you want to select, and then just email it back to me.
Okay.
Or, you can always print it out, and but that's always an option for some, but I've got some that don't have printers, so I really got to change the format up because mailing exams out at this time is not really viable for me on this end. So I got to come up with a format that essentially can be done on the computer and not with a printout and then either taking pictures of it or scanning it back, because not everybody has that technology available. Okay. Does that clear that up?
Yeah.
Okay. Is there anything else?
I'm all set.
Anything else? Yeah, like I said, we'll pick that up Thursday. Thursday, I'm not going to have very much left. So essentially, we're done with the Nukes packet. Now, essentially, just finishing that decay series and doing a half-life problem is really all that's left on Nukes. And we can go through some of the Nuke Tech PowerPoints on Thursday. So that's what I've got planned for Thursday. Anything else? And then next week we'd be starting Unit 4, which is the last unit. I'm sure y'all got the email about they're running it as online the rest of the semester. So we will not be going back to campus. But they should have sent you that email out. So hopefully everybody got that. So is there any questions on that?
No.
Okay. Well, if there's no questions, I will park the bus and I'll get this recording uploaded as soon as we end. Okay. If not, everybody take care and stay healthy, and I will see you Thursday. Okay. Take care.
Thank you.
You're welcome.